Join me as I dive deep into the debate and try to find out if glass is really a solid or something else entirely. Glass. We use it every day, from the screens on our phones to the windows in our homes, and even the cups we drink from. But have you ever stopped to think about what glass actually is? Is it a solid, a liquid, or something entirely different? Understanding the state of matter of glass is more than just a fascinating topic. It has real-world implications for industries like construction, manufacturing, and even space exploration. Glass is a material that has puzzled scientists for centuries, and at the heart of the mystery lies a fundamental question: is glass a solid or a liquid? On one hand, glass appears to be a solid. It has a fixed shape, it's rigid, and it doesn't flow like a liquid. On the other hand, glass doesn't quite fit the traditional definition of a solid. Its molecules are arranged in a random, disordered pattern, unlike the crystalline structure of most solids. This strange duality has sparked a lively debate among scientists, with some arguing that glass is simply a very slow-moving liquid, while others insist it's a unique type of solid. One major issue with trying to classify glass is that it doesn't follow the typical rules of thermodynamics. When a liquid cools, its molecules will normally settle into a crystalline pattern, releasing heat energy in the process. But glass doesn't do this. Instead, its molecules just sort of freeze in place, retaining their random arrangement. This means that glass doesn't have a distinct melting point like most solids, and it can be molded and shaped without undergoing any significant phase transitions. Historically, the debate over glass's state of matter has been influenced by its manufacturing process. Ancient glassmakers would heat a mixture of soda and silica to incredibly high temperatures, then rapidly cool it to create a rigid, amorphous material. This process was refined over the centuries, but it wasn't until the early 20th century that scientists began to seriously question whether glass was truly a solid. Some argued that the rapid cooling process was what prevented glass from forming a crystalline structure, essentially trapping its molecules in a liquid-like state. As we delve deeper into the science behind glass, it becomes clear that its unique properties are a result of its atomic arrangement. Glass is made up of a network of silicon and oxygen atoms, which are bonded together in a way that's both strong and flexible. This allows glass to exhibit some very unusual behavior, such as its ability to be molded and shaped without breaking, or its tendency to slowly flow over time. These properties have led some scientists to propose a new category of materials, the amorphous solids, which would include glass, as well as other materials like plastics and gels. Despite its rigid appearance, glass has properties that challenge our traditional definitions of solids. Its molecules are in a constant state of motion, even at room temperature, and they can be influenced by external factors like temperature and pressure. This has led some scientists to suggest that glass may be more akin to a liquid than we typically think, though it's still a far cry from the flowing, free-form liquids we're familiar with. So, what does it all mean? In the end, glass is indeed a solid, but it's a very special kind of solid, one that blurs the lines between our traditional categories of matter. This unique classification has important implications for fields like materials science, engineering, and even architecture. Thanks for joining me on this journey into the strange and fascinating world of glass. Do you think glass is more like a solid or a liquid? Let me know in the comments below. And if you're looking for more videos on cool scientific topics, be sure to check out my channel for more content like this.